Here's an exercise. Create a method that takes as input an integer n, which you can assume it's non-negative, and prints n with its digits reversed using recursion. So let's first call this thing reverse digits, takes as input an int n, and returns nothing. So what do we need? Well, first of all, we need a base case. So if n is less than 10, then it's a single digit, then I just print n. And otherwise, I can just do the following. I can first print the last digit. Then I can just call reverse digits on n with the last digit removed, which is just basically n divided by 10. So then we have the following code. Public static void reverse digits takes as input an int, and if n is less than 10, then I print n, then otherwise I print n%10, and then I reverse digits on n over 10. And now when I call reverse digits on, say, 5230, then it should print 0325, as shown below. And one way to shorten the code actually is to notice that when we have system.out.print n, it's the same thing when n is less than 10 as system.out.print n%10. So if you wanted to, you could also do the following. System.out.print n%10, then if n is not a single digit, then we can just reverse digits on n divided by 10. And the program still works, as shown below. Here's an exercise. Create a method that takes as input two integers and returns the greatest common divisor, where this relationship always holds. So how would I do this? Well, first the base case is GCD of 0, b is b, and GCD of a, 0 is a. That's always true. And now for our recursive step, we have that GCD of a, b equals GCD of a%b, b, and we also have GCD of a, b equals GCD of a, b%a. So then how would I do this? Well, first, obviously the base case, if a is 0, then return b. If b is 0, then return a. Then otherwise, how do we know which one of these two we want to do? Well, we want the one that gets us closer to the base case. So, when does this get us closer to the base case? When a%b ends up being less than a, or in other words, when a is greater than or equal to b. So if a is greater than or equal to b, then return GCD of a%b, b, because then a%b would be closer than a to the base case. And then otherwise return GCD of, well, a and b%a, because then a would be less than b, so then b%a would be less than b, which means we're closer to the base case. So now all that's left is to implement this. Public static int GCD int a int b. If a is 0, return b, and if b is 0, return a. Then otherwise, if a is at least b, return GCD of a%b and b. And finally, if a is less than b, then return GCD of a and b%a. And now when we do GCD of, say, 24, and 27, it should be 3, as shown below. And now, another way to do this would be to do the following. First of all, if, say, b is 0, then return a, and then ensure that a is going to be greater than b by doing the following. So return GCD of b comma a percent b. And this uses the fact that GCD of a and b is equal to GCD of b and a. And for this one, now, this thing makes sure that, well, b is always going to be greater than a percent b, since by definition the remainder should be less than b. So then we always get that the first number is greater than the second element after this call. And then afterward, we're getting that a percent b is always going to be closer than a to the base case. So this works as well, as shown below. Here's another exercise. Create a method that prompts the user for words until the user enters a dash. Then print the words in reverse order and use recursion. So for this one, first we need a base case. The next word is dash. Then otherwise, recursive step. Store the next word, right? Accept as input the next word. Then we can use recursion. So if we call this thing reverse words, then execute reverse words, then print the stored word. And basically the logic of this is we basically store the word right here so that I can print it at the end, so that the earlier words I store will be printed at the end. And after I store the word, I execute reverse words, and then I print the word. So basically, for example, if I were to do A, B, C, and then dash, well, I first store A, and then execute reverse words, which I can assume prints C and B because I'm gonna make it work. Then I print A at the end. So then it would be CBA as we want. So we do the following. Take as input a word. Let's call it X. Then afterward, I check if X is dash, then stop. Then afterward, I can store the next word. Well, that's already done up here. Then execute reverse words. So reverse words. Then afterward, I just print the stored word. So print X. So basically, if we were to write this, public static void reverse words. So first of all, we need user input, so let's import scanner. Then down here, let's do the following. So first, we need a scanner. We don't want to redefine it every time. That's actually pretty bad. So let's make it a variable. So public static, let's just do scanner input equals new scanner system.in. Then afterward, inside reverse words, I do, well, enter a word. Or dash to quit. And then afterward, string word equals input.next. If word dot equals dash, then return. Then afterward, if word is not equal to dash, then I just do reverse words. Then I print the word. And it should work. So if I call reverse words, and then I run, enter a word or dash to quit, QWERTY 456 Java dash, and then Java 456 QWERTY as shown below. Now let's do the following. Determine the output of reverse words if the user enters QWERTY, ASDF, ZXC, and dash. Now, of course, we know that it outputs ZXC, ASDF, and QWERTY. That's not what I want. What we want is to use the systematic way to determine the output of a recursive method we did earlier on this method. So how do we do this? Well, reverse words. So the first thing we notice is that we can't do it directly on reverse words with no parameters because, well, first of all, we don't know what word is, so we don't know whether this specific call will return or whether it'll call reverse words. So therefore, we must realize that reverse words actually secretly takes as input what the user enters. So then, even though it's not a parameter, it's still an input. So reverse words on the input, which is QWERTY, ASDF, ZXC, and dash. And then what does it do? Well, here word equals QWERTY, and then reverse words. Execute reverse words on ASDF, ZXC, and dash, then print word. So now, what does reverse words on ASDF, ZXC, and dash do? Well, word equals ASDF, execute reverse words on ZXC and dash, then afterward I print word. And actually print word I can just really say is print QWERTY in this case. And same thing right here, print ASDF in this case. Then reverse words on ZXC and dash. So what does that do? Well, word equals ZXC. Then afterward, I execute reverse words on dash and then print word. So then, in this case, word is just ZXC. So, and since word doesn't change in this method call, we have print ZXC. And now all we need to know is what reverse words on dash does. So what does that do? Well, word is dash and then we stop. We return. So that's equivalent to just doing nothing. So again, this is just equivalent to doing nothing. So then reverse words on ZXC and dash is equivalent to printing ZXC. And then this reverse words right here can be replaced with printing ZXC and ASDF, and we get that it prints ZXC, ASDF, and QWERTY. Let's finish with this exercise. Create a method that takes as input an integer n and returns an array list containing all binary strings of length n. So for example, binary strings of 3 would return this. And keep this ordering. So basically the natural ordering. So that would be 0, that would be 1, that would be 2, and so on. Just keep the ordering. So how would I do this problem? Well, first of all, we want to use recursion. So base case n equals 0, then return just an array list containing the empty string. Then if n is greater than 0, recursive step, then what I do is the following. So first of all, we store binary strings. So how would we do the recursion? Notice that the left half of the array right here is literally just, well, we take 0, 0, 0, 1, 1, 0, 1, 1, and add 0 to each of them. And notice that 0, 0, 0, 1, 1, 0, and 1, 1 is literally just binary strings of 2. And over here, same thing. So we're basically just taking every element of binary strings of 2 and adding 0 to it. And same thing for here, except adding 1 to it. So we just want to call binary strings of, well, n minus 1. List equals binary strings of n minus 1. And now what we do is the following. So first we need an array list to store this thing. So let's just call it result. Then afterward, I do the following. For every element in list, so for every element, let's just call it x in list, I do the following. Add, well, 0 plus x to result. Then for every element x in the list, add 1 plus x to the result. So what does this do? Well, this creates the left half of the array right here, so like that. And this creates the right half of the array, like that. Then afterward, we just, well, return result. So let's program this then. Public static array list of string, which, by the way, we need to import, so import java.util.star. Then let's call this binary strings, and then int n. Then if n is equal to 0, then I just return an empty array list of string. So since we need a result anyway, let's just create a result first. Array list of string result equals new array list of string. If n is 0, then result.add the empty string, then return result. Then otherwise, we do the following. Array list string, let's just call it list equals binary strings of n minus 1. And now, for every element in the list, we add 0 plus that element into the result, and then similarly we add 1 plus s to the result. And notice that we cannot combine these two for loops because that would mess up the ordering that we want. Then afterward, we just return result. And now if we call binary strings of, say, 3. So first, what would that print? That doesn't print anything. It returns an array list. So now what would list be? It would be what we wanted up there. 0, 0, 0 all the way up to 1, 1, 1. And now we have a list that contains all the binary strings of length 3, which we can easily access now. And we can do that for any n.